So in chapter 3, we talk about e-commerce infrastructure. So in this chapter, we want to understand how you will set up your infrastructure. You guys know if you open a shop, you need to have maybe a place to rent. Maybe you need to focus on your location. You need to decide on the decoration inside. You may want to check, the utilities available: internet, water, electricity. You may want to make sure you have parking for your customers. You may want to check you have space for your people to work. Maybe if you're doing some activities, you need to have the equipment necessarily. Maybe you need a photocopier. If you're a shop that do a lot of papers, you may need to have, let's say, if you're a restaurant, you need to have your kitchenware, your equipment, your ovens, your. So here we're talking about this e-commerce infrastructure. What do you guys think? What do an e-commerce, businesses need?
A virtual place, which is the website.
You need your website. Let's see what we've got here. Google Glass, Augment My Reality. Have you used any augmented reality applications? Do you guys know what's an augmented reality? Some reality that is virtual. Anyone?
Can you give us example and we get like something almost you see it like in reality?
Yeah, anyone have been to Second Life? SecondLife.com.
Sir, is it like when you went to the movie and it was the glasses and
Yeah, you wear glasses and then you're in a different life, and then everything you see, you touch, it's a real virtual. What do you guys think of any privacy issues raised by augmented reality applications? You live in another life. Anyone have played the games where you're like almost a human being inside this virtual
you mean like Xbox?
Xbox maybe
I have
games?
played.
Okay. Now some of these, if you go to this augmented reality, you go to this website and then you live there as if it's a second life. There's one called Second Life, and inside there you live, you work, you get paid, you earn, you make money, you buy things, and then they started to make it where people actually have to pay real money for you to buy the things that you want in your second life or in your augmented reality.
Is it a game
It's more like an entertainment.
or it's really?
It's an entertainment. And what is the revenue model? Sometimes they make advertising. For example, what is it? HSBC, they have a branch in Second Life game. So if you're playing in this, Second Life, augmented reality, you see HSBC. Do you see? And then that kind of, remind you with the HSBC in reality. Maybe there you can buy stuff, and the things you buy there will be, let's say, you go into this game and you get to know other people, and then you like those people, and you start to buy them gifts. Then the gifts that you buy them, you have to pay for them. So let's see. So the internet technology background: internet is an interconnected network of thousands of networks and millions of computers. It links businesses, educational institutions, government agencies, individuals. You guys know what's the World Wide Web? One of the internet's most popular services. So the www is really a service of the internet, and it provides access to billions, possibly trillions of web pages. So the idea of internet is just the network, and then the www is what you see through the browser. The innovation phase was in 64 to 74, creation of fundamental building blocks, and then institutionalization, large institutions providing funding and legitimization until 95. And the commercialization phase, which is after 95 till now, when you have private corporations take over, they expanded the internet backbone and the local service. So what is the internet? The key technology concepts. Internet defined as a network where you use IP address. You guys know what's an IP address?
Yes.
So you guys know the TCP/IP.
Protocols.
That's the protocol that allow computers to talk with each other, and it provides services to the users in a manner that is similar to the telephone system. So just like you have a telephone system, and then when you pick up, you get this tone, and then you dial a number, and it will reach you to the other destination. The same thing with the IP address.
Voice over IP.
And there are three important concepts. We've got the packet switching. Now, if you noticed here in our building, in every floor, there is like like routers there. Those routers that you connect the cables for the network. This way, can you communicate? Now, what happens is that the information when they move from one router to another, from one computer to the other through the internet, we call this each piece of information is like a packet, and then we've got this packet switching where if I'm online and I request that I want to go to this YouTube site, then my computer will send a packet request that will go to the internet provider and ask them I want to go to YouTube, and everyone will tell it go to this direction, go this direction, go to this IP until we reach to YouTube. YouTube will reply back and say okay, what do you need, and then all of this information going back and forth. They go through packets, and these packets are switched from one router to the other, from one machine to the other, from one network to the other. TCP/IP is communication protocol. That's the protocol that everyone understands, like the language. And then we've got this client service server computing where you have a client and then there is someone who serves you. For example, here this is a client, and then there is some sort of a server that will provide the information we request. Packet switching, it's slice digital messages into packets. It sends packets along different communication paths as they become available. Reassemble packets once they arrive at the destination. Uses routers. You guys know what's a router? Okay. And special purpose computers that interconnect the computer network. They make up the internet route packets. Routing algorithm, it ensures packets takes the best available path towards the destination. So if I'm going to download a lot of, let's say, 1 megabyte of information from another website, it will not come to me as 1 megabyte. Rather, it will come small packets. Those small packets, when they arrive here, they get together and they form whatever it's intended for them to form. And it is less expensive. And it's wasteful than circuit switching. So which one is more expensive, circuit switching or the AI packets? The circuit switching is more expensive, and the packets are very cheaper, and
Much less.
there is less loss in the packets than circuit switching. This is a packet. Let's say you have this message. Let's say it says, "I want to communicate with you." Text message digitized into bits. So it will be 0, 0, 1, 0, 1, 1. No, all of these zeros and ones, they represent this message. And, the computer systems, they will take the I, convert it into a number. Space, convert it to another number. W into another. And then those 0 ones will become a digital bits broken into packets. So maybe every 8 will be together, and then those 8 will be sent through the networks. Header information added to each packet indicating destination, other control information, how many bits are the total message, and how many packets. So if you want to download 1 megabyte of information, it will be 1 megabyte. It will be transferred to zeros and ones, and then those zeros and ones each will be a packet. Each packet will have an information where it's coming from, where its destination, and then they try to transfer. TCP/IP is a transmission control protocol. That's what's TCP. Establishes connections among sending and receiving web computers, and it handles the assembly of packets at the point of transmission and reassembly. So that's what the protocol do. The Internet Protocol provides the Internet addressing scheme. So you guys know the Internet addressing. It works like a 3-digit. They call it IP4, where they've got this IP and IP4 IP, where it's let's say 192.168.1.1. That's the network. That's the IP addressing scheme that is currently used. We've got this new version 4 or version 6, where it is more longer. For TCP/IP layers, we've got those are the TCP/IP layers. We've got network layer, internet layer, transport layer, and application layer. So if you look at the internet, it's got those 4 layers. The network interface layer is what?
The browser itself, the client itself.
That's when what? That's when you have a network. So let's say if you have got a website and I want to access your website, number one, we need to have a network. So we need to have some sort of a connection, okay? And then we need to have the internet where it will allow the HTTP. And then we need to have the transport, which includes, what type of information will be sent and coming. And then the application is what software. Do you see? Let's say, for example, I want to, have a mobile phone. First, I need to make sure that it has Wi-Fi, so I can connect. Number two, I need to make sure that there is an internet in the network. Wi-Fi is not enough. You need to have internet, and then after you have the internet, you want to make sure that you can access to whatever system you want to reach to. Let's say you can have a service to allow you to connect to this, let's say, the market. And then you need to have the application itself. Let's say you need to have the Facebook application. TCP/IP architecture. Here we've got this TCP/IP protocol architecture. These are the layers. Here is the network. We've got this, the internet, which is the first. The second, you have the IP, and then here you've got the TCP/IP host to host to allow you. Then applications is that what specific application you want to do. IP4 and IP6. Do you guys know what is IP4? This is an example of IP4. IP6, we don't have an example, but they're normally very long. Okay, and so those are the IP address. Are you guys okay with this? How many people feel they're lost? You feel you're lost? So here, if you look at this screen in my laptop, we've got, this is the old way of numbering, and this is the new version 6 numberings when you do an IP config on your command prompt. Okay. So we've got routing, internet messages, TCP/IP, and packet switching. Here we've got, let's say, this is a sender, this is a recipient. And then this is to, from. We've got routers to reach the recipient. TCP/IP breaks data into packets. Packets will travel from the router to a router over the internet. TCP reassemble the packets once they reach the destination. Okay. Now you can notice here with the internet is that the information can go through any available route in order to reach the destination. Now, do you guys know what's a domain name? So a domain name, it's let's say www.google.com. So google.com, it will be the domain name. IP address expressed in a natural language. So you can say liuyemen.com, facebook.com. Now those domain names systems, which is the DNS, it allows the numeric IP addressing to be expressed in a natural language. Now if I want to go to a Google website, I write google.com. That's the domain name. But in fact, the computer networks, they don't know Google, rather they know the address of Google, which is a number. So so that's where this domain name system, it will convert those natural names into the numbers so that you can go to that website. And a uniform resource locator is a URL, is when you have this long address that tell you exactly where to go to a specific document. You guys are okay with this? So if I try to go here, if I go here and I say, what is it, ping, you don't have to memorize these commands, but if I do a ping Google, this is really the address of Google. It's 82.114.163.53. So that's when I go and I write google.com, the computer system will immediately go to this number because that's where the pages are. And then client-server computing, powerful personal computers, clients connected in network with one or more servers. Servers perform common functions for client, like storing files, software applications, and access to printer. So that's the client-server computing. For example, if I have my email on Google, then Google server will be the servicing, and I will be the client accessing the information. The new client mobile platform, in a few years, primary internet access will be through tablets, smartphones. 33 of all cell phones, they have internet, maybe more. Cloud computing. What is cloud computing? Firms and individuals obtain computing power software over the internet, like Google Apps. Anyone has used Google Apps like the Gmail that we use, the calendar, the Google Docs. Faster growing form of computing, and it is radically reducing costs of building and operating websites and infrastructure and hardware. So instead of we have a mail server here and you have a mail server there and a mail server there, we have a one mail server at Gmail, and they provide this service for all the people. You see, so instead of you have a printer, you have a printer, you have a printer, we put one server that has the printer, and then everyone can print through this one same printer. Internet protocols, you guys know what's an HTTP? That's how you get to the internet. There's also some other protocols like the SMTP, POP, IMAP. These are email protocols. FTP or Telnet, SSL, TLS. These are also other protocols that does file transfer. So maybe if I want to transfer my files from this network to another network, I can use FTP because that's a file transfer protocol and it's good for transferring. And there are also some utility programs like the Ping and the Trace RT. So those are the examples I just showed you. Let's see, use this Trace RT.
Just bring for Google.
I do tracertgoogle.com. This will show me how to reach to Google website, and this is the address of Google. And here it will start to show me the network from here, my laptop, all the way to Google. So it show you this. It starts from my laptop, and this is the network I go through. This is the other following networks, and then I go to this. So these are all the machines that will go from here all the way to Google and back. And it show you here, you know, how many seconds. This is like milliseconds to reach. So 1, 2, 3, 4, 5. You know, the fifth will reach me to client3.google.com, and that's the IP address of Google.
But this is for the nearest server of Google, not to that.
This is the nearest Google available. Internet today, internet growth has boomed without disruption because of the client-server computing model. So if you look at if you think about, let's say, if you talk about your mobile operator, all of you need to go through the mobile operator. And the mobile operator has all of the switching through the mobile operator. If you think about the telephone network, it all has to go through the same central. Now with the internet, there is no one center. There is no one owner of the internet. So if I want to set up a network here in LIU, I can have my own internet, and I don't care about the rest of the world. You see, you can make another network there, and it has nothing to do with the world. And if we connect, and we don't care about the rest of the world. So the idea here of a client server is that every time you put a server, other people can be clients on. This has made the internet growth very popular. Okay, the hourglass layout architecture, network technology, substrate, transport services, and representation standards, middleware services, applications. So all of these made the internet to grow very fast. So this is the hourglass model of the internet. We've got this layer number 1, which is all of these. Do you guys know what's DSL? You have a DSL at home,
Yes.
like the internet access. Some of you use satellite. Anyone have used the satellite internet? Some people have wireless. Do you see those wireless everywhere? You open, you find,
Yes.
you know. And then there are some people that have internet through a coax cable, like through a cable, fiber optic, maybe LANs, local area networks. So that's first, it's a network technology substrate. Layer 2 is that you start to have the TCP IP and the IP4 and 6. And that will allow the information to transfer between all of these. And then you've got this other layer, which is the file systems, authentication, identity, security, storage. Let's say if you go here, you open your mobile phone, you have Wi-Fi, and then you connect to a wireless network, and then the wireless network, they should give you an IP address. Once you have the IP address, you can have authentication. You know, what is your username and password to the network. And then after that, you can check your email or web browse or image. So you guys are okay with these 3 or 4 stages?
So we do this all the time, please.
We've got this internet network architecture, backbone. Backbone, it's the high bandwidth fiber optic cable networks. So we have the internet. Let's say if you open your wireless, it's not very fast because you're not connected to the backbone. The backbone is like the backbone of the internet. We've got private networks owned by a variety of network service providers. Bandwidth, what speed you have. Built-in redundancy, on the backbone, the internet speed will be something like 155 megabyte per second to 2.5 gigabyte per second, or gigabit, right? IXP, it's a hub where backbones intersect with the regional and local networks. Backbone owners connect with one another. So IXPs, that's where they connect big networks, big backbones. And the CANs, land operating within a single organization that leases internet access directly from regional or national carriers. So maybe we want here to be connected to the to the backbone, then we need to go through a CAN. So this is an example how the networks work. You've got Office, connect, let's say campus network, connect through our domain. We can have our email, our POP, regional host, let's say we go through Telemann. And then here it will connect us with the other hosts in the world and connect to the backbone of the internet where it connects to the whole world. And then we also have maybe a domain local ISP, let's say regular phone line, home client IP addresses. This is like local ISP, let's say Yemennet, what they provide. Internet service providers. Do you know what's an ISP? Like Yemennet and Telemann, they provide lowest level of service to the individual, small businesses, some institutions. Types of service, narrowband dial-up. Do you guys remember the dial-up by through the telephone? Broadband, we have DSL, cable, T1, T3. Do you know what's a T1, T3? That's a faster internet. Satellite through the satellite. We've got intranet. Well, an intranet is a TCP network located within a single organization for communication processing, used by private government organizations for internal networks. So the intranet is very local. It doesn't connect with everyone else, and all internet applications can be used in private intranets. Who governs the internet? Is there a government for the internet? There are some companies or organizations that influence the internet and monitor its operations, including this ICANN. So this ICANN, they assign the names and numbers. IANA, Internet Assigned Numbers Authority. IETF, the Engineering Task Force, Research Task Force, Engineering Steering Group, the Architecture Board, the Internet Society. Remember the Internet Society, we invited them last year here. Internet Government Forum, WWW Consortia, W3C, Internet Network Operators Groups. So these are all individual groups that control the internet because, they don't control, they rather govern or influence. The keyword is influence. They set the standards so everyone may coordinate together. Government regulation surveillance on the internet. How is it possible for any government to control or censor the web? What do you guys think? Can the government censor the net? Do you know what censor mean? It's control. For example, if you go to the internet, they don't allow some websites. They close websites. They tell you these websites are not allowed. If you try to, there are things they say this is against our religion. You can't see. These are against our politics. You can't see. These are against our ideology. You can't see. We don't like this. You can't see. Is it possible for the government to do that?
People have VPNs.
People try, but VPNs are always there.
Still, they can you program it. It's hard.
See, the Chinese government, do they have the right to censor content on the web, or the U.S. government? See, the Chinese government, they said no Facebook, you can't use Google in our country, and you see it's illegal to use that. So the same thing for the U.S. government. Sometimes they allow, certain websites they can't operate, or they're not allowed, or it's against laws.
There's a lot of search engines, not just.
So here we've got, how do you think the companies should deal with the government? How many people are with censoring? How many people say no censoring?
No censorship.
What will happen to the e-commerce if the existing web split into a different web for each country?
It will lose its core benefits.
So imagine that the Chinese government says in order to access the internet, we need to check your passport. And according to that, we are allowed to see these websites. Then the government of Europe says if you're only Europeans, this is what you can see. The rest of the world you cannot see. Or maybe they tell their people, you're not allowed to see the rest of the world. This is the only thing you can see. And then we'll start to have the internet as like, by passport, where you're from, and then that's the information you can see. So that's an area for
So
discussion.
it will lose